Hi, welcome back to my YouTube channel Harita Tech Learning. Today we are discussing about APB protocol. APB stands for Advanced Peripheral Bus. It is a part of AMBA family of protocols and is mainly used for connecting low speed peripherals. APB is designed to be low cost, simple to implement, low power consuming, easy to understand. Unlike high speed buses, APP is not pipeline, meaning it handles only one transfer at a time. Because of this simple design, every APB transfers require at least two clock cycles to complete. Why APB is used? APB is mainly used to access control registers inside peripheral devices such as UART, timer, GPIO, SPI, I2C controllers. These peripherals do not require high speed data transfers, so APB is a perfect choice. APB signals are peak clock is clock signal used to synchronize all APB transfers. P reset and active low reset signal used to initialize the APB interface. P address bus that specifies the peripheral register location. P selection select signal used to choose a specific peripheral device. P enable indicates the access phase of APB transfer. P write defines transfer direction, high for write, low for read. PW data carries data from requester to peripheral during write operation. PR data carries data from peripheral to requester during read operation. Applications of APB protocol connecting low speed peripherals to processor systems. Register access for control and configuration. UART communication interfaces, GPIO controllers, timer and watchdog peripherals, SPI and I2C controller interfaces, interrupt controllers, power management and system control blocks. Operating states. This diagram shows the APP protocol state machine with three states. Ideal state P selection equal to 0, no transfer is happening, bus waits for a new request. In setup state, P selection equal to 1, P enable equal to 0, transfer starts here. Address, control and write signal become valid. This state lost for one clock cycle. Access state P selection equal to 1, P enable equal to 1, actual data transfer happens. Read or write operation completes. State transitions. Ideal to set up when a transfer request starts. Set up to access new clock cycle automatically access to ideal. A transfer completes no next request. Access to setup if another transfer starts immediately. Access remains access when period equal to 0, meaning peripheral need more time. Write transfer. Whenever there is no transfer on the APB bus, P selection should be 0. That is called ideal state. And whenever the transfer start first, the peripheral will get selected by making P selection as 1. And along with the P selection, the other control information like write data address will also be available on the bus at the same cycle. And here P enable will be low, and this state we call it as setup state. So the setup state is like the state where the transfer has been started, and in the second cycle P enable will be go high, and the APB peripheral will complete the transfers at the passage of P enable. Here data 1, the state is called enable state. So on APB for every transfer it means two cycles. So the setup and enable state, then once the transfer is completed, again in next cycle P enable will go low, and if there is again no transfer to be done, so again it goes back to the ideal state. Again, if there is extra transfer to happen, so we need to go to the back to ideal state and then start with again setup and enable. So after setup enable, immediately the setup state can start. P selection, P address, P write will be placed on the bus on the same time in the same cycle, and in the first cycle again here P enable will be low, in the next cycle P enable will go high, and the APB peripheral will be the PR data available with respect to P enable, and the transfer will completed at this cycle, and this is called again enable state, and again in the next cycle P enable will go again back to 0. If you found this video helpful, please like, share and subscribe for more content.